From scrap metal to heavy plates, see how gym weights are born. A wooden pattern of a plate is pressed into green sand. Top half, cope, and bottom half, drag. Runners and vents are cut by hand. A small sand core is placed in the middle, so the hole size stays exact for the barbell sleeve. Two workers tilt a ladle and fill each mold slowly. The metal flows through the gates and settles flat. Molds rest until the plates turn dark red. Then the boxes are opened and the rough castings drop onto a grate. A cut-off wheel and a hammer remove the extra metal trees. The plate shape is now clear. Castings run through a blasting drum. Steel shots hit every side and wipe away sand, rust, and scale. A bench grinder smooths the rim, faces, and hub. The center hole gets a quick hand ream to ensure a smooth slide onto the bar. Each plate goes on a digital scale. If it's heavy, a worker kisses a hidden spot with a grinder to hit the exact target. Plates hang on hooks, get a thin primer coat, then a tough baked enamel or powder coat. Raised numbers are hand wiped with bright paint. A quick gauge checks the hole size. Surfaces are wiped clean. Plates are paired, wrapped, and boxed, ready for the gym floor.
Ever seen animal bones turn into drinking water pipes? Give me 1 minute and I'll show you how. One smart factory said, don't dump bones, use them. Let's follow the simple trip from bone to pipe. Trucks bring big cow and goat leg bones to the factory. Workers wash and weigh them. Only clean, solid bones stay. Water jets blast off all meat. The bones dry in a hot drum until crisp. Crushers snap them into chips. Fast grinders spin the chips into smooth bone powder, softer than flour. The powder is full of calcium. Mix 1 scoop of bone powder with 9 scoops of melted plastic. The mix looks like cookie dough, but acts like super glue. The hot blend pushes through 2 long screws and out a steel mold as a glowing tube. Cold sprays freeze the shape. Robots slice perfect 6-meter pieces and print bone pipe on each. Some pipes go to the lab. Machines pump water until they burst. Normal plastic splits early. Bone pipes bend first, so crews see trouble before flood. These pipes are stronger, lighter, and faster to install. Crews need fewer cranes, save fuel, and cut costs. The planet wins too. After 50 years, old pipes are shredded and heated. The plastic turns into fuel. The bone powder is cleaned and used again in fresh pipes. Bones to pipes. Ways to wonder. Like and subscribe for more smart recycling stories.
Ever wondered where a tractor gets its lifting muscle? Today we're inside the factory to watch raw steel transform. Each batch is scanned for cracks and measured for exact thickness. Cutters trace the arm's outline like a laser-sharp cookie cutter, slicing through steel in seconds and leaving smooth, burr-free edges. Heated to a glowing orange, the blanks move under a 1,500-ton press. The die stamps in the signature curved profile that lets the arm clear tire treads while still lifting straight up. After cooling, robotic mills drill pivot holes in machine oil channels to within 1/10 of a millimeter. Reinforcement ribs. Each seam gets an ultrasonic scan. Any porosity means an instant re-weld. Into the furnace, the arms go for hardening, then a rapid quench in oil. This balance of hardness and flexibility stops cracks during rough field work. Shot blasting removes scale, and a zinc-rich primer fights rust. Finally, a tough powder coat in trademark tractor red is baked on for a showroom shine. Chrome-plated pistons, seals, and high-pressure hoses slot in. Every connection endures a 250 bar pressure test, well above real-world loads. Torque wrenches verify bolt tightness. Laser gauges confirm alignment, and a final lift test hoists a 2-ton weight. Past arms head to packing and ship out worldwide. Ever wondered where your beat-up slippers go? Watch how these grimy flip-flops get reborn as shiny new footwear, separating rubber from fabric and pulling out any metal pins. The slippers ride a conveyor into a rotating drum filled with hot, soapy water. Large paddles tumble them hard, shaking off years of street dust. They exit the drum and pass under spinning nylon brushes that scrub every surface, then cascade through high-pressure spray nozzles for a crystal-clear rinse. A heated wind tunnel blasts the clean slippers. The blades knead everything into a sticky, speckled dough. Operators load the dough into steel molds shaped like slipper soles. Hydraulic presses clamp down, heat up, and fuse the mix into solid, springy blanks. The molds open. The soles pop out sizzling hot. A conveyor carries them beneath rotary knives that shave off excess flash for a clean outline. Fresh PVC straps are injected straight into pre-drilled holes, locking tight as they cool. A worker flexes each pair to prove the bond is solid. Each slipper meets a soft buffing wheel that smooths the footbed, then passes a quick visual check and a weight test before boxing. Watch a flat sheet of steel turn into a strong, shiny box in just 1 minute. A giant coil unwinds, sending smooth steel sheet onto the line while pinch rollers keep it tight and straight. A quick strike notcher bites small triangles from each corner so the edges fold without bumping into each other. Robotic press brakes fold the blanks like origami, forming crisp 90-degree walls in 4 rapid hits. Twin welding guns clamp every corner, shooting electric sparks that fuse the steel edges into one solid piece. A spinning flap will schemes along along each weld, removing burrs so fingers won't snag later. Automatic riveters fix heavy-duty hinges to the lid and body. Then a robotic arm snaps them together for the first open and close test. Boxes ride through a hot, soapy spray tunnel that strips oil and dust, perfect wrap for paint. Charged paint powder floats onto the grounded steel, glossy skin that laughs at rust. Workers add locks, rubber feet, and a foam seal, then test the latch with a satisfying click. Every box is weighed, wiped, and inspected. Good ones slide into cardboard sleeves, ready to ship worldwide. Ever wondered where your empty water bottle ends up? First, huge trucks pour mountains of used bottles onto a moving belt. Workers and smart cameras quickly sort out any metal, glass, or paper. Only clean plastic heads forward. This saves time, energy, and keeps the final product here. A row of roaring grinders chops the bottles into tiny flakes, like colorful confetti. The flakes dive into giant washing drums filled with hot, soapy water. Dirt, labels, and leftover soda float away, leaving shiny, clean plastic pieces. Next, the clean flakes slide into a long, hot tunnel called an extruder. Inside, spinning screws melt the plastic into thick goo. The goo squeezes out through tiny holes, cools instantly in water, and snaps into rice-sized pellets, perfect fuel for new products. Pellets shoot into a powerful injection molding machine. In seconds, liquid plastic fills a chair-shaped steel mold. The mold slams shut, cools, and opens, revealing a one-piece commode seat with built-in legs and lid. No screws needed. Robotic arms trim rough edges, while quality staff sit, press, and twist to test strength. Any weak chair gets recycled again. Nothing is wasted. And that's how yesterday's bottle becomes today's bathroom essential. Recycling symbol keep recycling. Ever wondered where your old copper pipes? Mountains of used copper arrive at the recycling yard. Everything from snap plumbing tubes to tangled electrical wire. Workers and magnets pull out steel screws and plastic bits because pure copper brings the highest price, while heavy copper granules drop into waiting bins, 99% clean without a single chemical added. Inside a rotary furnace blazing above 1,000 degrees Celsius, the granules swirl like liquid fire. Oxygen lances burn off the last traces of oil and paint. Within minutes, the metal becomes a glowing, lava-smooth pool. Operators tilt the furnace. Molten copper slides into graphite molds and cools into 200-kilogram pigs. Ingots re-enter a reheat oven, then squeeze through giant rolling mills, thinning from brick-thick slabs to coin-thin sheets. Some sheets feed a drawing machine that stretches them into hair-thin wire, ready for tomorrow's smartphones and EVs. Copper is infinitely recyclable. Almost 80% of all copper ever mined is still in use today. So the next time you recycle a copper scrap, remember, you're not throwing metal away. Have you ever stopped to wonder how a simple brush scrubs mud off your favorite jeans? Railcars unload pellets of recycled polypropylene for the handles, while bales of nylon and Tampico fiber wait for bristles. Moisture meters check each batch. Dry pellets and clean fibers mean fewer defects later. Orange hot plastic shoots into a steel mold shaped like a palm-friendly block. 40 seconds later, robotic arms pop out a perfectly formed handle still steaming from its 220 degrees Celsius berth. An air jet cools it, then a conveyor lines it up for drilling. A CNC head punches dozens of 4mm holes in less than 5 seconds. Precise spacing is key for even scrubbing. Another cutter carves a thin anchor groove around each hole. The groove will lock the bristles in place. Watch the sewing machine on steroids. It pulls a U-shaped loop of nylons. Next, a high-speed grinding wheel flags the tips, splitting each strand into tiny microfibers that grab dirt without scratching fabric. A hot stamp machine presses the company logo in silver foil onto the handle. Inspectors flex the bristles 10,000 times. Finish brushes slide into a paper sleeve made from 80% recycled pulp. Ever eaten off yesterday's shampoo bottle? Stick around, you'll see waste plastic reborn as shiny dinner plates. Only food-safe plastics, smart, and move ahead. Clean feed equals safer plates. Rotating knives slice bottles and tubs into popcorn-sized flakes. The flakes dive into bubbling hot water with EcoSoap. Labels, glue, and ketchup residue float away, leaving bright, food-grade plastic bits. Giant air tunnels blast the wet flakes dry. They tumble straight into an extruder, an extra-long, heated screw. Inside, flakes melt into smooth, syrupy plastic. The syrup squeezes through tiny holes, cools, and snaps into rice-sized pellets, perfect recipe for new plates. Pellets drop into a high-speed thermoforming line. Sheets are heated until floppy, then slammed between mirror-smooth plate molds. Vacuum pulls every ridge tight, creating a flawless surface. In just 2 seconds, plate form. Laser blades kiss off the extra rim. Cameras inspect color, thickness, and strength. Any rejects re-enter the shredder, zero waste, endless loop. And that's how yesterday's plastic trash becomes today's dinnerware. Safe, strong, and dishwasher ready. Recycling symbol eat smart, recycle smarter. Like and follow for more factory magic. Huge bins of mixed-grade steel scrap roll in. A powerful magnet lifts the metal and drops it onto a roaring conveyor. Inside the shredder, spinning hammers break the pieces small, while air jets blow away rust and dust. Clean chips travel up to a 1,800 degrees Celsius induction furnace. Melt together. Two dies slam shut with 500 tons of force, flaring one end into the familiar mushroom head that locks against the tractor hitch. Excess flash is trimmed off by a ring cutter in the same stroke. No wasted motion. Onboard lasers measure every cut. Bad readings stop the line instantly. Pins ride through a controlled atmosphere furnace at 880 degrees Celsius, then quench in oil for rock-hard strength. After tempering, they tumble in a zinc bath for corrosion resistance, emerging with a bright silver coat that laughs at rain and mud. A robotic carousel gauges length, hardness, and pull-out force. Anything under spec is binned for recycling back to the melt shop. Approved pins snap into blister trays, slide down a chute, and drop straight into printed boxes, ready for farms worldwide. A roaring shredder rips the metal into palm-sized flakes. These chips ride a conveyor through a rotating washer, where jets of hot caustic water strip off paint. The aluminium liquefies into a silver pool. Operators skim off floating dross, those dark oxides that would weaken the casting. Molten metal flows through a ceramic filter and into sand-coated dies shaped like a kettle shell. Within seconds, the outer skin solidifies. After 5 minutes, the whole casting is cool enough to lift. Robotic arms crack open the molds and transfer each rough kettle to a trimming press. Excess flash is sliced away. Then the body spins on a lathe where carbide bits shave the rim perfectly round. Separate spouts and handles are die-cast from the same recycled melt. A TIG welder fuses them to the body. Clean joints, no leaks. Quick dip in water checks for pinholes. Kettles tumble with ceramic media, then fly against buffing wheels for a mirror polish. Finally, an anodizing bath seals the shine and resists kitchen stains. Inspectors tap each kettle for a clear ring, screw on the whistle, and slip it into a recycled cardboard box, ready for the next cup of tea. A high-speed press punches hundreds of perfectly shaped laminations every minute. These thin steel discs will stack into the stator and rotor cores that power the fan. Precision here means a quiet, energy-efficient motor. Robotic arms wind enamel-coated copper wire around each stator slot with millimeter accuracy. Automatic varnish dipping then locks the windings in place, improving insulation and lifespan. Aluminum end rings are die-cast onto the rotor stack, creating a squirrel cage rotor. The rotor is spun on a dynamic balancer. Tiny metal chips are shaved off until vibration disappears, ensuring whisper-smooth operation. Fan blades start as flat aluminum strips. Hydraulic presses curve, taper, and punch mounting holes in one motion. A quick pass through a deburring drum removes sharp edges. Both blades and motor housings enter an electrostatic booth where dry powder paint clings like magic. Technicians fit the rotor into the stator, add silent running ball bearings, and detach the decorative housing. Balance blades are bolted on, followed by the down rod and canopy. Every bolt is torque checked for safety. Each completed fan spins on a test rig for 30 minutes. Sensors verify speed, current draw, and noise level. Only units that pass 100% of checks receive the factory seal. Ever wondered what turns a flat sheet of steel into the reliable gas stove in your kitchen? The journey starts with large coils of mild steel. Automated lasers slice each coil into flat blanks. Hydraulic presses then stamp those blanks into the familiar top panel, sidewalls, and bottom tray, precision holes already punched for burners and controls. Robotic benders curl and fold the stamped parts, locking strength into every edge. Spot welding arms fuse brackets and supports so the frame can handle years of cooking heat without warping. Next, the raw metal takes a bath. It's degreased, rinsed, and dipped in an anti-rust primer. After drying, an enamel powder coats the parts. Inside an 800 degrees Celsius oven, the powder melts into a glass-hard finish that resists scratches and stains. Meanwhile, brass pellets drop into induction furnaces and melt, the liquid creating rings lined with hundreds of tiny gas ports. CNC machines drill and polish each port so flames spread evenly. Precision-turned brass valves control the gas flow. They're paired with venturi tubes that pull in air for a clean blue flame. Technicians grease the valve stems and snap on heat-resistant knobs. Every stove enters a sealed booth where compressed air checks for microscopic leaks. Passing units ignite on a test line. Inspectors look for a steady blue flame at every setting. From clear oils to creamy, fragrant bars, watch a beauty soap come to life. Oil and lye flow together into a steam-jacketed kettle. An anchor stirrer turns slowly as the mix heats to 90 degrees Celsius, triggering saponification, the chemical reaction that creates soap. When the mix thickens, workers add brine. Fresh soap rises like cream, while glycerin-rich water sinks. 10 minutes later, every strand smells heavenly. The scented noodles pass through 3 chilled steel rollers. This crushes tiny air bubbles, giving the bar its silky, dense feel. steel. A plata screw compresses the soap into a warm, continuous log, then cuts uniform billets, future bars, every second. Hydraulic presses slam a custom die onto each billet, embossing the brand logo and trimming crisp edges in one fast hit. Fresh bars ride a spiral conveyor through cool air for 20 minutes, setting up firm enough to wrap. Inspectors weigh random bars, snap them to hear the clean break, and sniff for consistent scent. Failures head back to remelt. Automatic tuck-fold machines wrap each bar in foil, slide on a paper sleeve, and pack dozens into cartons, ready for store shelf. From raw plastic pellets to a road brightening beam, watch a motorcycle headlight come to life. Aluminum ingots drop into an induction furnace, melt to liquid silver, and pour into bowl-shaped dies that set in seconds. Robotic wheels polish each reflector mirror smooth, then a vacuum chamber pops a chrome layer on top that bounces every ray of light forward. High-frequency vibration fuses the lens to the reflector lip in milliseconds. No screws, no leaks, just a tight plastic bond. Silicone rings press into place. A tiny one-way vent snaps in to let air out but block water, stopping fogging on cold mornings. Printed circuit boards slide onto an automated line where robots solder surface mount LEDs and a mini heat sink for cool, bright light. A vision camera guides a microarm that positions the LED exactly at the reflector's optical focal point. Accuracy to 0.05 millimeters. Workers wipe each lens, scan barcodes, and click the wiring harness in place before stacking headlights in shopproof cartons. Precision optics, tough plastics, and a splash of science. That's the bright secret behind every motorcycle headlight. See rusty scrap steel reborn as mirror-bright tablespoons. Workers tip buckets of bent cutlery. Clean scrap drops into a 1,600 degrees Celsius electric arc furnace. Crackling blue arcs melt the steel into a glowing orange lake. Operators rake dark slag aside, then shovel in nickel and chromium pellets, vital for stain-proof, food-grade stainless steel. Liquid metal pours through a water-cooled mold, solidifying into square billets that slide out glowing cherry red onto a rolling table. Billets pass through a train of heavy rollers, slimming from thick bars to shiny strips barely 2 millimeters thick. Hissing sprays keep them cool between passes. A flywheel press claps 200 times a minute, punching perfect spoon shapes, bowl and handle together from the strip. Hydraulic presses stretch each blank's head into a smooth bowl while the handle stays flat and strong. Rotary knives shave tiny burrs. Simple grooved rollers curl the handle edges so they feel soft and stiffen the grip. Inspectors weigh, flex, and shine each spoon under bright lights. Past pieces drop into velvet-lined trays, ready for dinner tables worldwide. From scrap heat to silver shine. Watch leftover animal bones transform into elegant jacket buttons. Operators feed each bone across a thin circular saw, shaving 5 mm thick slabs, perfect thickness for sturdy buttons. A hand-fed fly press stamps neat circles from every slab, spitting out dozens of bone coins with a satisfying clack. Coins slide under twin sandstone wheels that level both faces, keeping each disc a uniform 3 millimeters thick. Discs tumble inside a spinning wooden barrel full of fine gravel. After 10 minutes, the edges emerge, silky smooth and fingertip safe. A simple bench drill pierces 2 or 4 neat holes through each disc. A wooden jig keeps fingers clear and spacing perfect. Buttons spin on a leather wheel while a worker brushes water and pumice paste across the surface, raising a gentle satin shine. 4 darker shades. Buttons soak in natural dye, walnut husk or tea, then dry on mesh racks, locking color deep into the grain. A beeswax-charged cotton wheel buffs every button to mirror brightness. Inspectors tap, weigh, and bag them by the hundred for garment makers worldwide. From butcher's leftovers to fashion finish. From raw leather to ready-to-wear sandals. Craftsmen shave the leather edges to half thickness. This keeps seams flat and comfy on the foot. Foot pedal punches add air holes and size marks. A hot brass stamp presses the brand logo near the heel in one crisp hit. Sewing operators guide each upper under a simple lock-stitch machine, joining lining to outer leather with heavy nylon thread. A thin cotton tape is glued along stress points. Then uppers slide over a warm metal last where they cool into a smooth foot curve. Foam sheets feed through a slicer that sets final thickness. A rough wire brush scores the bonding surface for better glue grip. Soles enter a manual hydraulic press with a pattern plate. 30 seconds of heat imprint deep, non-slip grooves. Brushes spread rubber cement on both parts. After a 3-minute tack-off, workers align toe first, then press the heel down firmly by hand. Rotary knives shave excess foam. Sandpaper wheels smooth the rim, and a waxed cotton wheel buffs the leather to a warm glow. Care, heat, and a few skilled hands. That's the journey each pair of sandals walks before it walks with you. From crushed drink cans to bright silver wire, smaller pieces melt faster and save energy. A toothed shredder chews the bricks into chips. The chips pass through a hot drum that burns off paint and labels. Clean water jets rinse away ash and dust. The chips ride a screen to shake off the last droplets. Chips tip into a gas-fired furnace at about 750 degrees Celsius. The aluminum turns into a bright liquid pool. An operator schemes gray dross from the top, then adds a small dose of alloying metal to hit the right strength. Molten aluminum flows through a casting wheel and comes out as a thick, round rod. Water sprays cool it as it moves. The red-hot rod runs through several roller stands that slim it down to an even wire rod coil ready for drawing. Coils unwind through a mild cleaning bath, then a soapy lubricant. This lets the wire slide smoothly through dies. The wire pulls through a row of hardened dies, each one smaller than the last. With every pass, the diameter gets thinner and shinier. A low-temperature oven softens the wire to the right temper. Operators check springiness and make sure it stays straight on pull. From raw rubber to a squeaky clean swipe, blade strips pass through a hot tunnel that cures the rubber so it stays springy and won't crack. Operators pull the strips over a guide bar, then a hand-fed guillotine chops exact lengths, 30, 45, or 60 centimeters. Aluminum coil runs through small roll-forming stands to make a U-channel. A foot pedal press punches screw slots along the bar. Polypropylene granules melt in a simple injection press. Each head pops out with a threaded socket ready for the handle. Steel or aluminum tubes are cut to length on a chop saw, ends are deburred, and a plastic cap is tapped onto the tip. Handles hang on a moving rail. A hand sprayer coats them evenly. Then they bake in a low oven for a chip-resistant finish. A worker slides the rubber blade into the channel, aligns the slots, and tightens small screws or clips along the bar to lock it in. The channel seats into the plastic head. 2 rivets or screws clamp the parts together, keeping the blade perfectly straight. The handle screws into the head socket. Each wiper gets a quick pull test and a swipe across a wet glass plate to check edge contact. Size stickers go on. See a rusty steel rod reborn as a strong wheel spanner. Trims it to a handy L spanner size, about forearm length. Into the forge it goes until the tip glows bright orange, soft and ready for shaping. Hammer blows drive the drift in and out, turning the hole into a neat 19 millimeters or 17 millimeters, hex for lug nuts. Back to the anvil. Light taps around the sides sharpen the 6 flats so the spanner grips cleanly. The other end is heated and pulled over a bending fork in the vise to make a strong L shape. Short arm with socket, long arm as the lever. While warm, the handle gets gentle hammer marks for a non-slip texture. Sharp edges are kissed with a hand file. The whole tool is reheated to a dull red and left in air to relax stresses so it won't crack in use. Only the socket end is brought to cherry red and quenched in oil. This gives a tough, wear-resistant bite on nuts. A quick rewarm to straw yellow color draws the temper so the head won't chip. The handle stays springy. A wire wheel shines the steel. A thin coat of black paint protects the handle. The spanner clamps onto a wheel nut. Tighten, loosen, perfect fit. Then it's wiped and set aside, ready for the road. From plain steel rod to tough handmade chain, watch it come together. A hand shear or cut-off wheel chops neat pieces, each one a future link. The ends of a blank go into a coal/gas forge until orange. On the anvil, light hammer taps taper both ends slightly, a scarf for a strong weld later. With tongs, the hot blank wraps around a steel mandrel, forming a clean oval. A small gap is left where the weld will close. Before closing, the hot link drops into a sizing die. A few hits make every oval identical. A straight edge checks that the chain hangs true. A whole section is warmed to dull red and air-cooled. This relaxes stresses so the chain stays tough, not brittle. A hand file and a wire will smooth the seam. Any sharp burrs are removed so the links won't snag. For a black, rust-resistant skin, the warm chain dips in oil and is wiped clean. If your video shows paint or zinc, show that here instead. The chain takes a pull test on a simple jig. Length and size are stamped. Then the coil is tied and set aside for delivery. Heat, hammer, and skilled hands. That's the secret behind every handmade chain.